All right, we need to pick back up from 6.1. So we're just going to practice a few things with the matrices that we've learned. So this is still 5.1. Alright, so this is kind of like the warm-up we just did, but it wants you to write the system. So let's write out the system. Remember that this is your X column, that's your Y column, your Z column, and then equals. So this first row would be 1x plus 0y plus 7z equals -5. Your second row would be 0x and then 1y minus 5z equals 15. And then your third row is just z equals -26. Okay, then we want to back substitute. So I already know z. So let's plug this in. Let's just go to this one first and find y. So that's y minus 5 times -26 equals 15. So that's plus 130. So y equals -115. I don't need y to find x because my first equation just has x and z. So I will again plug z, -26 in for z. So that's x plus 7 times -26 equals -5. So that's minus x minus 182, is that right? So x equals 177. Okay, so then my solutions as an order triple, x, so 177, y, -115, and z is -26. Okay, so remember our goal is going to be to get this triangle of zeros, because once I get the triangle of zeros, then I can find my variables by just plugging them back in. Okay, so we're going to work on doing row operations to do that. So this problem just wants me to practice with some row operations. I'm not actually triangularizing yet. And we're going to write the new matrix. So I'm going to do these one at a time. So that will be my first step, and this will be my second step. Okay, so the first step here says that I'm going to swap, I want to swap row 1 and row 2. So I'm just going to switch their order. So I'm not changing anything, but I am going to switch their order. So I use this little symbol as a symbol to use for matrices, like saying equals, it means equivalent. So equivalent matrix. So these will be equivalent matrices, just the rows are swapped. Okay, so I'm going to write row 2 on top. And then row 1 is now row 2. Row row 3 did not change. Okay. Then from here, I'm going to do the next step. So this was step 1, and now I'm going to do step 2. I'm going to write step 2. Okay, so what this says is to do -4 times row 1, add it to row 3, and then that's going to replace row 3. So the only row that's going to change is row 3. Yes, I'm going to multiply times row 1, but that's just to help me get a new row 3. Okay, so I'm not changing row 1 and row 2. So I'm going to go ahead and write row 1 and row 2, just copy those down. Okay, so I'm not changing those. So I'm just copying those down because what's going to change is row 3. So when I do that change, I'm not going to write it as in a separate matrix because then it gets kind of confusing on what stays and what goes. So I just do the work right here on the matrix. So I'm going to do -4 times row 1. So that's right here, all right? So that's -4, -4, -8, and -24. Okay? So I just write them as little numbers right there, and I'm adding that to row 3, and that's giving me a new row 3 after I add those together. So -4 plus 4 is 0. -4 plus 1 is -3. -8 plus -3 is -11. And -24 plus 2 is -22. And there's where we're stopping on this problem. So our goal, though, when we're solving is to get that triangle in zeros. And these are the type of things I would do to get that triangle in zeros. So if you look right now, I have 1 0, and I want to get zeros in the other spots. That will be my goal. So this question asks, what row operations would we use to get those zeros? So it talks about the diagonal. So here's the diagonal. Okay, that's what the diagonal is. And it wants to know what row operations would produce zeros beneath the first entry. So 1 is the first entry. So how could I get a 0 here and a 0 here? I would want 1 here as well, but I can't really figure that out until I had zeros in the other 2 places. So we'll just talk about how we get zeros there. Okay, so first of all, here. I want to get a 0 here. So that'll be my first step. Okay, so I'm thinking elimination. I'm going to use row 1, and I'm going to multiply row 1 by -3. And the reason why I multiply it by -3 is because then I get -3 plus 3, and that's 0. So I'm going to do -3 times row 1, and I'm going to add that to row 2. And the row that I want to change, where I want the 0 to be, would be row 2. So I always put a little star next to what's actually changing, so then I don't get confused when I write the new matrix. Okay, so that's how I get a 0 there. Now, let's see how we get a 0 here. I'm going to use row 1 again. So what would I multiply row 1 by then? So I want to multiply row 1 by positive 5, because 5 and negative 5 would give me 0. So 5 times row 1, and I'm adding it now to row 3. And that will become my new row 3. Yes?
You have to add it, like, you have to add it to row 2 or row 3. So you change row 2 to row 3.
Yes. It needs to be part of what you're adding, yes. But sometimes you'll multiply by the one you're replacing too when you add. Like sometimes you have to multiply both rows in order to get it to cancel to get a 0. Okay, so remember our goal is to get a matrix that looks like this with the triangle of zeros. So if you notice, it doesn't matter what I have in row 1, because I don't need zeros there. I need zeros in row 2 and row 3. So row 1 is not going to change. I will use it to help me get zeros here, but I'm not actually going to be changing row 1. All right, so let's do a practice then. So I want to triangularize the matrix and then back substitute to find the values of my variables. So let's say this is the matrix we're starting with. Okay. So the first thing I want to do is triangularize. Well, row 2 is actually good because I already have a 0 where I need it in row 2. So the only thing I have to worry about is row 3. And I have to do it one at a time. I have to get zeros in one spot at a time. So when I do this, I would go in order. I would find this 0, and then this 0, and then this 0. Since I already have a 0 in my step 1, I don't have to do that. I don't have to worry about that there. But I would go in that order. So I want to start with the 4 to try to make that a 0. Okay, so I'm going to start right here. So I want to get a 0 right there where that 4 is. I need to use row 1 to help me because if I use row 2, that's going to, I'm not going to be able to cancel a 4. Like no matter what I multiply 0 by, I get 0. And if I add that to 4, I'd still have 4. So that's not going to help me. So I need to use row 1. So what should I multiply row 1 by? Negative 2. So negative 2 times row 1 plus row 3. And what row do I want to change? 3. That's where I want the 0 to be, so I'm changing row 3. So before I do the multiplying, so I don't get confused, I'm only changing row 3, so I'm going to copy down row 1 and 2. Before I do the multiplying, and I can't remember what my original numbers were, I want to copy down row 1 and 2. Okay, so now I'm doing negative 2 times row 1. So if you want to write the negative 2 out here, like if that helps you, feel free to do that. So negative 4, positive 6, negative 2, and positive 2. And I'm going to add that to row 3. So that gives me 0 7, negative 3, and 12. Okay? All right, so now I only have one more spot I need to change. So I have to change that 7. I have to use row 2 and 3 here, because if I use row 1 again, so let's say you use row 1 and you, I don't know, either way you would have to multiply both. So let's say you use row 1. Well, if you did 2 times 7 and got 14, 14 plus 0 is 14. And so then you'd end up with 14 right there and not 0 anymore. Okay? So you want that to stay 0, so you have to use row 2 and 3. And to get 7 to cancel with a negative 5 or with a 5, you're going to have to multiply both. So I'll want to multiply row 2 by negative 7 and row 3 by 5. Now you could switch and do positive 7 and negative 5. That doesn't matter. And then again, I'm still just wanting to change row 3. So before I do that multiplying, I'm only changing row 3, so I'm copying down row 1 and 2 again. So we see why we had to multiply by negative 7 and by 5, why we had to multiply both. Because that's how they would cancel. I need to use 35. Okay, so 0 times negative 7 is 0. 5 times negative 7 is negative 35. Negative 7 times negative 2 is 14. Negative 7 times 7 is negative 49. Okay, 5 times 0 is 0. 5 times 7 is positive 35, so that's what I needed to cancel. That's negative 15 and 60. So add those. So 0 plus 0 is 0. Negative 35 plus 35 is 0. 14 and negative 15 is negative 1. And negative 49 plus 60, 11. Okay. Now we triangularize. We did the triangularizing. So now we can back substitute to find my variables. Okay, so negative 1z, so negative z equals 11. So z would be negative 11. Okay, plug that into the second equation. So 5y minus 2 times negative 11 equals 7. So that should give me negative 3 for y. And then plug both of those into the top so you can find x. So 2x minus 3 times negative 3 plus 1 times negative 11. So minus 11 equals negative 1. So you should get 2x equals 1. So x equals 1/2. That's what you guys got? Okay. So then my solution is x, y, z. 1/2, negative 3, negative 11. Remember how to check your answers. Go back to the original. Plug them in to check. Questions about that? Okay, we're going to do another one. Okay, so this time we need to start off and write out the augmented matrix. So write out the matrix for the system. So first row is 2, 3, 1, and then vertical line, so equals 5. And then your second row, there's no x, so 0, 2, negative 1, 7. And then 1, negative 1, negative 2, 5. Again, I already have a 0 in row 2, so I'm not going to need to change row 1 or 2 at all, because I'm good. Row 1 can be whatever. 2, I just need a 0 in the first spot, so row 1 and 2 are good. So let's start in the bottom left. How could I get a 0 there? Why don't you write down the row operation you think you would use? So write it down and then I'll call in something. Okay, Carly, okay. Times R. Good. Yep. So negative 2 times row 3 plus row 1 is going to give me my new row 3, because that's where I want the 0 to be, is in row 3. So copy down row 1 and 2 so because you're not changing those. And then you can do your multiplying. So I'm going to get negative 2, positive 2, positive 4, negative 10. Okay, I want to add that to row 1. That will give me 0, 5, 5, and negative 5. Okay. Okay. So now I'm almost there. I just need a 0 right here. So again, to do that with the zeros in the first 2 spots, you have to use row 2 and row 3. Okay, so what will I want to multiply row 2 by? Negative 5. Okay, and then I want to add that to row 3, but what am I going to multiply row 3 by? 2. And what row am I replacing? Row 3. Okay, so again, I have not changed row 1 and 2. Okay, negative 5 times 0 is 0. Negative 5 times 2 is negative 10. Negative 5 times negative 1 is 5. Negative 5 times 7 is negative 35. 2 times 0 is 0. 2 times 5 is 10. 10, and then negative 10. Okay, so add. So 0, 0, 5 plus 10 is 15. Negative 35 plus negative 10 is negative 45. Okay, back substitute. You got your triangle. Z will be negative 3. So you have 15z equals negative 45, so z is negative 3. So y, 2y minus 1 plus or times negative 3 is plus 3 equals 7. So 2y equals 4, y equals 2. Okay, and then let's find x. So 2x plus 3 times 2, so plus 6, plus 1 times negative 3, so that's minus 3, equals 5. So 2x plus 3 equals 5. 2x equals 2, x equals 1. So 1, 2, negative 3. Remember to check your order triples. Go back to the original equations, okay, up here, and plug in. So plug in for x, y, and z. All three, make sure you get true statements. Okay? Questions about that? Okay. So we need to talk about special cases because we have 3 variables. So sometimes if all your variables cancel, you'll get no solution. Sometimes you'll get infinitely many solutions. So if it's no solution, it's going to look like this. You're going to get 0, 0, 0, 0, and then a number. So the 0, 0, 0 means you have no variables left. They all cancel. And that's saying 0 equals 7. Well, I know that's false. That is not true. So that is no solution, or what we've called inconsistent. Sometimes you get infinitely many solutions if all your variables cancel. And because there are 3 variables, there were 2 types of infinitely many solutions. You had linear dependent and coincident dependent. So linear dependent, you get 1 row of zeros, because that tells you that that 3rd row was equivalent to one of the other 2 rows. So you had 2 equations that were the same. Okay, so that's 0 equals 0. That's your infinitely many solutions, because that's true. 1 row means it's linear dependent. So you write your solutions in terms of a parameter. We'll come back and do that for this for this in just a second. Let's go ahead and talk about this one. So coincident, you would get 2 rows of all zeros. That tells you all 3 equations were the same. You use set notation for this. So that looks like you use braces for set notation. So x, y, and z, and then such that, use that vertical bar, and then just copy down the first equation. Now you have to put the variables back. So 1x plus 3y minus 5z equals 4. And that's it for the set notation. Okay, let's talk about writing this as a parameter now. So to write it as a parameter, you want to go to the row that has just 2 variables. So you want to start here. So that's 3y plus 4z equals 7. And you need to solve for one of those 2 variables. So let's say we'll solve for y. So that's negative 4z plus 7. And then divide by 3. So either way you do this one, you're not going to have very nice parameters. You're going to have to deal with some fractions, but that's okay. A lot of times you will. All right, so I solved for y, and that's in terms of z. So that means my parameter is z. So I have a y equals, and then I know z equals z. That kind of tells me that that's going to be my parameter. Okay. So now I need to plug this in to the top, because that's the only other row I haven't used. I need to plug this in for y, so I can get an x equals. So I have a y equals and a z equals. I need an x equals. So I have to plug this in to y. So that's 3x, and then it's plus 1y, so just exactly what you have for y. So minus 4/3 z plus 7/3 minus 5z equals 2. You need x equals. So let's go ahead and combine our like terms, our z's there. Negative 4/3 and negative 5 is negative 19/3. Subtract 7/3 from 2. That's negative 1/3. I want x equals, so I'm going to add 19/3 z, and then divide everything by 3. And then I have my x equals. So writing this in as a parameter, so I have my x, my y, and my z. I say that x, y, z, that order triple, goes to 19/9p, because z is my parameter, minus 1/9. That's x. Y is negative 4/3 p plus 7/3. And then z is my parameter, so p. Not very pretty. So that's linear dependent. That's if you get all zeros for one row. So you don't know necessarily from the beginning that it's going to be linear dependent. That just you start triangularizing, and if you get a row to completely cancel out, then you know, oh, okay, well, it's some type of dependence. So for example, if we look at this problem, it says solve each system by triangularizing the augmented matrix and using back substitution. Okay, that just means let's triangularize, let's try to get values for x, y, and z. But it could be dependent or inconsistent. If it's linearly dependent, give the solution in terms of a parameter. If it's coincident dependent, write the answer in set notation. So, first thing, write it as a matrix. I want to triangularize. And remember, I said I started with row 2 if need be. So I need a 0 right here where the 4 is. So I'm going to start there. I want to get that to be 0 first. So I think using row 1 would be most helpful. What should I multiply row 1 by? Okay, so -2 row 1 and plus row 2. What row am I changing now? Row 2. So I'm not changing row 1 or 3, so I'm going to copy those down. So -2 times row 1, so that's -4, 2, -6, and -2. Okay, let's add those. So that gives me 0, and then I get 0, 0, 0. Okay. I get a row of zeros, so that tells me that this is dependent. I don't know yet, though, if it's linear or coincident yet. I have to check the third one first. So this tells me here that it's dependent, but I don't know if it's linear or coincident. Okay, so I have to check the third one. So I still want to try to get a 0 here. And if I get another row of zeros, it's coincident. If I don't, if I just get the 0 where the 10 is supposed to be, then I have a linear dependent system. Okay, so what should I do to get a 0 where 10 is? -5 times plus row 3, and that'll be my new row 3. Okay, so I'm not changing row 1 or 2 this time. So row 2 is still just all those zeros. So that's -10, +5, -15, and -5. So I add that. 0, 0, 0, 0. So, because I have these 2 rows of zeros, it's coincident dependent. Which means I have to write it in set notation. So x, y, z, such that, and then write your first equation So 2x, so put the variables back in, minus 1y plus 3z equals 1. Technically, you could write any of the three, but this is the one that's still left in the matrix, the first one. So that is my solution.